So hello everyone, bonjour tout le monde. It's my pleasure to welcome you to the S-111 technical briefing with a special focus on Canada's West Coast. For those of you who do not know me, I'm the, newly appointed Director General for the Canadian Hydrographic Service, now heading soon into 3 months into the position. So at the CHS, digital transformation is certainly well underway, and today we're here to celebrate an important milestone in this journey, our advancements with respect to surface currents. We're thrilled to see future S-111 users joining us in such impressive numbers today and look forward to hearing your views and answering any questions you may have. So I will hand the floor over to Louis, who will be your host for this briefing. We hope that the session will provide you with valuable insights and deepen your understanding of our ongoing projects and activities. So thank you again for your presence and your support, and I do wish you all a very productive session. Louis, la balle est dans ton camp.
Merci Manon. Thanks Manon. So welcome everyone. So today we'll have an interesting session. So I'm Louis Maltais. I'm the director for navigation, geospatial services and support for the Canadian Hydrographic Service. And I'm joined today by Isabelle Gaboury. She's a manager with Ocean Science Branch within Department of Fisheries and Ocean, Canada. Dr. Phil MacAulay, manager of Dynamic Hydrographic Products, S-100, with CHS, will continue. And finally, we have Marc Leblanc, Regional Director of Canadian Hydrographic Service on the West Coast. That will close out the meeting. And after that, we'll have a Q&A session where everybody will be invited to contribute. And for the Q&A sessions, we could use the chat, or if you want to, raise your hand, you just need to give us your affiliation, your organization, and we'll give the floor to you and try to answer to the best we can. So important note today, we have 3 communities today on this call. We've got our navigation community, so the navigators from the West Coast. We've got the hydrographic community, and we've got the oceanographic science community. So we need to be mindful of that during that session. We're all speaking English today, but because of different communities, it's really important to be mindful of this difference so we can understand each other. The other thing is we've got 2 groups. So the primary focus today is, the navigation, so the future S-111 user on the West Coast, but we also have a lot of national and international observer, and it's great. But of course, for the Q&A session, we'll focus our attention to the question from the navigators, the pilots on the West Coast, and if we have time, we'll open up to the observers. So don't forget, make sure that in your language, in intervention, you're mindful of the differences. We created a PDF for the presentation today. So right after, I'm going to send via email the PDF. It's fairly small, so no issue. Everybody should be able to get that because we've got external participant. I cannot do a chat to distribute the presentation. So I'll circulate the PDF right after. Session is being recorded. So our plan is to make it available to social media, LinkedIn, and we'll try to make that happen in the next couple of days. Yeah, that's it for the rules of engagement today. So let's dive right in. Origin of S-111. So myself, I've been at it for more than a decade now. But, finally we're there. We're there today with, kind of what we consider to be the dream many years ago. And today, 3 years ago, I lost one of my S-111 buddy. So Kurt Hess from NOAA, I did work as I think we were making a great duo, me and Kurt. Kurt was the wise man, and I was, all excited. Okay, let's do this, let's do that. So, and try making it right. Kurt was really great. And the TWIC WIG, so the water level and current working group, we have a special mention in the specification for S-111. So I'm privileged enough to see the completion of that work today. Kurt didn't have that privilege, but I'm sure that he would be proud of what we were able to achieve and building on the work he did internationally to deliver on the product specification. So yeah, the dream is this. Surface currents included in GIS and ECDIS and different navigation system, and we're there today. So how S-111 compares to our classic offers? So again, focus on the West Coast. So on the West Coast, our prime products is the Canadian Atlas of Tidal Currents. So you'll see today the modeling technology that we're using is pretty amazing. It has the potential to do 3D currents. At some point we'll get there, but we need to be, again, mindful of where we are coming from. So moving to, a static prediction-based surface currents to a full-on forecasting of surface current is something that is quite a step forward. If we look at the IHO roadmap, where are we? So we are on the S-111 surface current. We are on the group that is being the prime focus at this time to be ready for 2026. So this is the route monitoring. So S-111, even if we are not, we're not in full approval of the official operational version, we wanted to roll this out early so we can adjust the service. We can make sure that we can report to IHO if there's issues with the format we're using. I don't expect many changes between the version we're using now and the version that will be fully endorsed. So I don't think there's a huge risk of having, software manufacturers starting to develop application to run on top of that. So route monitoring is the key piece now. We're working on these layers, and route planning is the next phase. So that's the IHO roadmap, and working with our Canadian colleagues and the interdepartmental S-100 Canadian committee. We've got the Canadian e-navigation roadmap. So the vision in Canada is S-100 is not just only CHS-led, it's a Government of Canada initiative. And the goal is we want to have, a Canadian S-100 service. And independent of who's producing the information layer, it will come, it will be standardized authoritative approach. So as you can see, bathymetry, surface current, we're almost there today. And of course, this is dynamic function of the request of our clients. We can, we can still move. So yeah, ENCs are coming up, and with our colleagues from Environment Canada and Climate Change, we have the ice charts and the weather layers coming up soon. So on that, so the approach we took is subscription-based. So the data as a service concept, where you connect to a service. We can support humans, but we can support machine. There is, a tremendous data flow getting out of CHS every day on S-111. It's almost impossible for a human to be able to follow that. So working with, our partners, we have developed APIs, machine-to-machine interface, where seamlessly you have access to S-111 surface current on your navigation device. At CHS, we have a S-100 national grid, and we have a rule of 3. So you see on the image here, we want to chart only at 3 scales, and if there is a navigation requirement. So there will never be an area in Canada where you have 6 products at different scale in the same area. Maximum 3 scales, so overview, your approach, harbor, it's kind of a classic approach. And we will apply that same scheme for all of our S-100 layers. So that's the Canadian rule of 3. Full value chain, of course, we're government, and when you're trying to innovate in government, it could be challenging. So we partner with the best in the industry. So the Primar Electronic Charge Center in Norway, Caris Teledyne, so Teledyne Geospatial for hosting in the cloud and leveraging the latest technology there, and 7 Seas on the quality control that we're trying to accomplish straight into the cloud. So this is our approach to try to deliver. And in our test, we were able to demonstrate that we can go all the way to the end, and Phil will talk about that later on, all the way to the PPU manufacturer able to deliver S-111. Nav versus non-nav. So for navigation, it's called S-111. For non-navigation, you get the 3 links down below. So nav, you go to Primar. For non-nav, office use, planning, demonstration, propaganda, you can use the MSDI current layer, or if you don't have this WMS capacity, you can also use the ArcGIS web application. So it's a public application where you can combine many layers from Government of Canada, including Canadian ENC images and S-111. Finally, great situation on the West Coast. Of course, we'll have to deal with transboundary issues with our colleagues from the US. Right now, we didn't cut along the border for surface currents. It's going to be a topic that we'll address during the Hydrographic, the US-Canada Hydrographic Commission, how to make sure that, autonomous vessels navigating from Canada to the US will sail on a seamless set of S-111 files. Finally, this is a world first, in my view. It's our best effort. But CHS, we existed 1883. It's the first time we're doing S-111 at high resolution. So we are expecting issues. And Phil did find some interesting issues last night, and he will cover that during his presentation. Isabelle, the floor is yours for the science.
Thank you very much, Louis. And so what I'd like to do today is give folks a little bit of a walkthrough for the science and technology underlying the surface current predictions. And so specifically looking at the ocean models. We do tend to look a little bit more broadly than just talking about ocean models. Really what we're looking at is port ocean prediction systems. So this includes not only oceanographic models, but also data feeds, how those data feeds are connected to the models, the post-processing. And so really a whole system for getting from observational data, knowledge of ocean processes to the predictions that are being made available. Just to give a teeny bit of background, this work was done under the first phase of the Oceans Protection Plan, so between 2017, 2022 for the bulk of it, during which time the goal we had set ourselves was to develop these port ocean prediction systems for the forecasting of currents, water levels, and water properties, so specifically temperature and salinity, for 6 ports and approaches on Canada's east and west coasts. These were split more or less evenly between the two coasts, so we haven't quite managed to cover the Arctic yet. So Kitimat Fjord, Port of Vancouver, including both Vancouver Harbour and the Lower Fraser River, the Strait of Canso, Port of St. John, and the St. Lawrence River estuary. As shown in the plots to the right here, I'm focusing just on the west coast ports today. And so looking at really Kitimat area from Douglas Channel up through Kitimat Arm, including some of the smaller channels around there, and then the 2 portions of the Fraser River around Vancouver Harbour, South Fraser. The modeling is done in 2 stages. And so for each of those locations, we have an approach model at 500 meters resolution. And then the actual port areas, which are shown in the little red inset boxes on the plots, are modeled at various resolutions ranging from 200 meters down to 20 meters, and I'll get into the details of that in a moment. The approach with the ports was to use a same general approach for all 6 ports so that we're consistent across ports and also with best practices nationally and internationally, but then to have those ports customized for the specific oceanography of the area. And so there's a general configuration which includes the downscaling strategy, which I'll explain in a moment, but basically how we relate to the larger scale models that we feed from. We have a same general circulation model, so the understanding of the physics and processes are the same types of inputs for the interaction with the atmosphere, and then the same approach to sequencing the information. So going from inputs, pre-processing, running of the models, and then post-processing of those outputs. But each of the models is configured and tuned for the local areas, taking in local input data. So while the overall approach is consistent, the models are very specific to the areas they're working in. Obviously, extensive validation has gone into the models. As with any oceanographic model, there's been the whole peer review process, scientific validation. In this case, going above and beyond that to some extent to ensure that we have a well-validated, thoroughly documented system, including quite a bit of comparison against in situ observational data, so location-specific data, including temperature salinity profiling, current profiling, and drifter experiments. If you can move to the next slide, please. Thank you. And so to dive into the technology itself a little bit, and this will be probably the densest slide, and I do have a couple folks from my team who will be happy to answer questions at the end of this. In terms of the model itself, and there was actually a couple of years of work that went into how do we actually choose a model for this. There are many approaches that are possible. What we settled on is called the Nucleus for European Modeling of the Ocean, or NEMO, which despite the name is global in application, not specific to European waters. This allowed us to benefit from having access to an open source, readily available model that has very strong support from the international community. In particular, we're working with a version of the model that is maintained across the Government of Canada, across science departments, including notably Environment and Climate Change Canada. And so having a nice solid base for the oceanographic processes. The models then take in a series of inputs. Because these are regional models, it's essential to link to the larger models so that we capture the larger scale oceanographic processes at a basin scale. And so the conditions at the edges of the domains for each model are taken from Environment and Climate Change Canada's operational ocean forecast models, specifically the Canadian Ice Ocean Prediction System, which has a scale of about 2 to 2.5 kilometers, and then the Salish Sea System. And so what we've shown at the bottom of the slide here is when we look at the port models, really we're looking at an element of a cascade of operational systems. So these are highly validated. The models in operations at Environment Canada are 24/7, extensively vetted. And so really looking, as I said, at a cascade from global scale to have those really large scale processes down to regional, down to coastal, including a Salish Sea model, which is a rather recent development. And then these then feed into the conditions at the edges of the port models, which are much more regional in application. So that's for the ocean conditions. Obviously, atmospheric conditions are very important as well to having accurate predictions. And so those we take, again, from an Environment and Climate Change Canada operational model, the high resolution deterministic prediction system atmospheric model. So this provides temperature, salinity, surface current inputs. So things like precipitation, winds, and so on. This is a coarser resolution model, 2.5 kilometers. But is the best available model and operational context. In general, we don't have ice modeling included in the ports. This is something we're working on for the St. Lawrence and other ports. This isn't a concern as ice is not a significant input. And then the other element we take in, and the only case where we're really taking in real-time data without going through this cascade of models, is getting inputs for real-time rivers discharge or water level data, in particular where areas where river inputs are important to the overall oceanography. we do, where possible, take in real-time gauge data with processes in place to fall back to alternative mechanisms if the data are degraded or simply not available. In terms of the sequencing, these models are forecast models, so they predict into the future. They're set up, as I mentioned, as part of an overall system. And so there's a framework that contains these models that take in the input data, take in the forcings, the parent models from Environment Climate Change Canada, handle some checks and fallbacks should any of the required inputs not be available. And then on a fixed forecast, take all those inputs, run the models, do the post-processing, and output the results. This framework typically works in a way where we have a daily what's called a nowcast. So essentially the models are run on a one-day time span to get in sync with the real-time input data, notably the gauge data. And then for each day produce up to 4 48-hour forecasts, so predicting 2 days into the future. The reason I say up to 4 is essentially once we get to more than 4 times daily, we're getting so far ahead of the parent models that we're just re-estimating the same thing essentially. And so the idea is that for each day, we have that 1 day run using the local data. And then that initiates a set of forecasts that are all based on those conditions from the past day. Moving on to the next slide. And so over the course of the Oceans Protection Plan program, we spent quite a bit of time developing these models, validating, comparing with observations, obviously working closely with our partners at the Canadian Hydrographic Service around formats, outputs, what would be needed from these models. And so all this came to a overall documentation, transition, and validation process. A key item of this for us, obviously, was to have the documentation and review around the models. DFO's tool for doing that is the Canadian Science Advisory Secretariat, which provides a process within a well-established now framework for providing peer review, especially peer review meetings, to provide sound, objective, and impartial science information and advice in support of DFO management decisions. These are meetings that are scheduled, including significant expert participation, and then having the outputs of those meetings in terms of both the advice and the science going into them being openly available afterward. And so this meeting took place over 4 days in March of this year. And the intent of the meeting was to review the port ocean prediction systems, their ability to represent real-world physical and ocean conditions and variability, to assess their stability and robustness, and then to provide some inputs on the appropriateness of the outputs for the intended uses. Important to note, this is a scientific peer review process. It's not a consultation process. It's not a policy process. It's really intended on making the information available. The meeting itself was very well attended. We had 30 participants from the Government of Canada, University of New Brunswick, Royal Military College of Canada, NOAA, the UK Hydrographic Office, and one person from the WMO. We went through detailed evaluations, so these evaluations were provided ahead of time and documented in research documents, providing the results of the last year or so of work that had been done. Comparing 5 to 6 year reconstructions of historical conditions from the models with available observations over the span of that time. And so really looking at the predictions from the models compared to the observations, so temperature, salinity, currents both at surface and at depth, drifter experiments. Looking at a long enough time span at over 5 to 6 years, we were aiming to capture not only typical conditions in the ports, but also some of the extremes. So we had some interesting storms, surge events, and so on. I think we had a hurricane in there somewhere. And in addition to having that validation against real world observations, also ensuring the stability of the models. So stability, we look at simply the computational stability. So can these models actually run and not crash all of a sudden, but also looking at the stability of the predictions. A risk always with forecasting is there's a tendency for the forecast to slowly deviate from the real world. And so looking at the stability of those predictions to ensure that they do stay in touch with the real world over the time spans that we're looking at having those predictions available. The meeting concluded over those 4 days. We were able to achieve all the objectives we'd set out to do. We're now in the process of publication of the document. So I have included a link in the document that will be available in the PDF. It is a bit of a process to get those documents out. We're currently going through translation of 600 some odd page documents and so on, but we are hoping to have those available within the next couple of months. On to the next slide, please. And so to give a little bit of an overview of the discussions that came from those conversations in March, and of course that summarizes the work that was done in the year or so leading up to that. The port ocean prediction systems have shown quite a bit of skill in predicting the water levels, currents, and water properties at the scales and for the regions at which we were looking to use them. So the hindcasts have performed well. The forecasts are working well as well. So good comparison against observations within, some limits that I'll get into a moment. In particular, and this is what was important to us, where there is overlap with the current best operational models, the port models generally worked as well as or better than the currently existing models. The port systems were also able to provide predictions for a number of areas for which we don't currently have coverage. So in particular, in those really near shore areas, we were expanding the ability to have those estimates available and also really increasing the resolution quite a bit. That being said, modeling is never a perfect activity. While the models performed very well and better than the operational models currently available in most cases, it's always important when using the model results to keep in mind the limitations inherent in that process. Notably that we're validating against available data. And so we have been collecting data over the course of the program, but there's always opportunity to get more data. And also the models themselves include certain specific processes. And so for the areas we're looking at, the important things to keep in mind, one of them is the use of the real-time gauge data for the freshwater inputs. These are not necessary everywhere. This is an important input where there is significant freshwater input. And so where there is significant input, the model outputs will be better where we do have those inputs and where the quality is good. We do have a series of mechanisms in place to ensure that if a tide gauge goes offline, that we're able to fall back gracefully to climatological averages. But it is useful and important to have that input available. Another important thing to note is there are some real complexities to the oceanography around intertidal areas. In particular, some really interesting processes around areas that wet and dry, and that affects the currents in particular. The version of the model that was available when we designed the port system, so NEMO 3.6, does not include wetting and drying. And so for areas such as Sturgeon Bank, Robert Bank, Maplewood Flats, where wetting and drying could be important, we found the best approach was to artificially deepen those to a minimum depth of 4 meters. We are looking at upgrading to newer versions of NEMO. We're working with Mercator International on that at the moment. But for the moment, there's some caution needed in those very shallow areas. As I mentioned, we can tune the models against observations. While the models are generally stable outside those ranges, obviously, if we're looking at a 1 in 100 years kind of storm or surge event, it's important to keep in mind these models are not necessarily tuned optimally for those. The other thing is also especially looking at some of the areas around Fraser River, for example, where we get into very narrow channels. There is a limitation to the model resolution. And this is actually why I mentioned earlier, we do have varying resolutions for the various models. Those were chosen to provide adequate resolution for navigational use while not trading over performance too very much. In some cases, actually, the resolutions were also chosen to ensure stability of some complicated oceanographic processes. There's some very interesting things that happen in the St. Lawrence that can cause some grief at models at very high resolution. And so in most places that resolution is adequate to capture local oceanographic features, but where we're really going into areas that have features on the same scale as that grid scale, so very narrow channels like Second Narrows, Princess Royal Channel, Grenville Channel, where the width of the channel is maybe 1 grid point, it's important to keep in mind that limitation in scale. On to the next slide, please. And so to summarize, to close out a little bit, so where we're looking at now, having gotten to these first versions of the models, we're fortunate under the Ocean Protection Plan to have funding for ongoing work on the models. And so we will be continuing to do research, development, and validation of the port ocean prediction systems, continue to improve the oceanography, overall functioning, exploring additional features, doing additional testing. So this is an area of active research and development for us. We do anticipate having future releases as we continue to have those updates. And so this is something that we'll be working with CHS to see when those future releases might be of benefit to delivery of navigation services. Just to highlight some of the things that we're currently looking into or investigating, as I mentioned, the implementation of a newer NEMO version, so 4.2 plus. We're actually working on both versions 4 and 5 right now with our international partners to bring in wetting and drawing in intertidal areas. We're continuing to do research on oceanographic processes, in particular looking at things like how we model waves, looking at dynamic ice models. It's important to know, though, these are not necessarily things where we have a roadmap of improvements. At this point, we're in the investigation stage. More processes does not necessarily always mean better results. And so it's a question of looking into these things and seeing which oceanographic processes, when added, actually improve the usefulness, accuracy, and stability of a model. Sometimes, slightly counterintuitively, more is actually represents a degradation. So that's where we're investigating these and then selecting those things that should be implemented in a future version. We're also very interested in looking at how we provide estimates of uncertainty along with the actual values. So looking at approaches such as ensemble sets, so running the model various times with slight perturbations to give a better estimate of the certainty and the errors around those estimates. Looking at the possibilities of expanding the gauge data that are available to better constrain those river inputs. And then continue to do that validation against observational data, in particular drifter experiments. This is where, and sort of to forecast a little bit where we're going with the presentation, this is an area where really there's a lot of opportunity for feedback from the end users. Models are very data hungry creatures, and so any feedback that we can have from end users is extremely valuable and continue to develop the models. Both cases where the models worked really well and perhaps even worked better than what has been available before, but also cases where the model did not produce the results that would be desired, didn't quite match up with the conditions. And so we're very interested in having feedback on how the models are working for the end user community. That is it for me. Thank you very much, Louis.
Thanks, Isabelle. Great overview of the science behind it and how serious business it is. Great collaboration between, the Ocean Science Branch and CHS. And I cannot reinforce how important your last bullet is about the user. You are the local experts. And you will be able to attest, what is the performance of the model. Even if you don't know anything about the science, you have important input to make sure that, we want in the end to have, iterative approach to our models, and your feedback is critical. So on that, we'll move to the science, so the operational delivery, and move with Phil MacAulay.
Hi, everybody. I hope that Isabelle has convinced you that a significant amount of effort has gone into creating those high-resolution models, and that they are in addition to the end of a long chain of work already been done and being done within DFO, Department of Fish and Oceans, and Environment Climate Change Canada. And so what I'm going to discuss is how we're using the outputs of those systems to provide the S-100 products. And it's specifically that what I'm calling the dynamic products. So that's basically environmental data, forecast, nowcast, prediction, and observations, and real time for water levels or at marine condition overlays, in this case being S-111. That's what we'll focus on today, but I will talk about S-104 as well. And we're providing that data in international hydrographic organizations standard S-100 formats, And so we can integrate those seamlessly with other S100 standards, the S101 electronic navigational charts, and S102 high resolution bathymetry within ECDIS and PPU shipboard and port navigation systems. So next. So the goals of this are essentially to enhance marine safety, to provide expanded windows of transit and port entry opportunity, to provide more efficient and economic ship shipping, and to prepare for emerging autonomous shipping. And at the bottom of the screen, you see the links to the IHO specifications for S111 and S104, so that you can go and look at those if you're so interested. Next. So before we go on to the details of how we produce the files and that sort of stuff, I thought let's have a look at what this is all about anyway. So up on your screen, this is a testbed portable PPU unit, which is showing S101 and S102 put together. So you have the standard sort of chart background plus that high resolution bathymetry draped across it. Next. So if we then add S104 to that, what we end up with is dynamic depths, meaning that because the bathymetry is referenced to chart datum and the S104 is also referenced to chart datum, we can put them together and have an instantaneous depth that evolves with time. And then you can do things like safety contours depending on the draft of your ship and things like that. Next. So this is now S101 and S111. So it's the overlay of surface currents on top of an S101 product. And then that's simply a picture of the PPU, I think, going down the St. Lawrence River. I believe that's what that's from. Next. Okay, so before we go on to the real details, I wanted to show you how this kind of works in a simplified way. So what we have here is an image of the Port of St. John, and we're going to see how ocean model data goes to S111 and finally to PPU display. So next. So the ocean model output is down in the middle there. You can see that there's surface elevation and surface currents, and that's just a small proportion of the model output, but that's what we use for at the moment. That then creates an S111 file, which can be put on top of a background image of the bathymetry of the S101, and then S104 again is put on top of the existing image, and S104 is looking pixelated because that's the resolution of the model itself, and so S104 is provided in the model squares because it's constant across the square. So next, so now we'll get into how it gets generated. You saw in Isabelle's talk that there's a big chain of solutions that gets you down to that high resolution. So in this case, I'm not even going into to talk about REOPS or any of the atmospheric models which force these ocean models, but essentially the chain that we care about is the REOPS to COPS to the POPS, which is our high resolution solutions. And we have 6 POPs that we're going to be supporting: Kitimat, Vancouver, South Fraser River, St. Lawrence Estuary, St. John's Harbor, and Strait of Canso. Next. So here's a flow chart of how those all put together and how they work for us. And in red, so I want to recognize that this is part of what for Canada we call a concepts system, and these are ocean model suites, as Isabelle pointed out. So Environment Climate Change Canada runs operationally those much bigger scale solutions, and then it comes to us where we have to run those other alternative scales to get down to our end products, which are those high resolution port scales. But if you look at that, what you'll recognize is there's a whole range of scales being produced, and we're going to sample all of them, not just the high resolution end products, but every part of the chain. So and it's a parent-to-child behavior where the parents force the children, and as I said, weather effects are added to all the forcing. So this is a picture of what we have to do at the CHS end, because the red solutions are all run operationally in Environment Canada in a really robust fashion. We're doing a best effort operation for all the blue suites that you see on the screen, and there are 11 suites. We're running them on what we call the General Purpose Science Cluster. It's a supercomputer that Canada uses for various applications. Each suite takes about 300 CPUs to run, and in each day we do a 24-hour pseudo-analysis, which is the hindcast that Elizabeth is referring to, and a 48-hour forecast. And we produce S111 and S104 files in post-processing associated with the whole system. And what you see below in the bottom corner is the Maestro scheduling, which Environment Canada also uses, where we schedule everything to happen. because everything has to happen sequentially for us to get down to the end products themselves. So that's a brief picture. And the blue elements you see at the right, those are models and post-processing that was already run this day, well, not this day, but a few days ago. And the yellow are the ones that are scheduled waiting to start the next day. And next slide, next, sorry. So in our best effort production, it's 24/7, meaning that it always runs every day. At the moment, we only have the resources to do all suites per one run per day. We only support it 9 to 5 during the week. You don't have staff on the weekends looking at this stuff, and we have no computational redundance, meaning that if our GPSC cluster fails in some fashion, or if we have container issues or software problems, we'll go down. And then we have to recover to bring the service back up when the computer comes back up. So that means that there's going to be downtime. As Louis said, this is a test system, and you got to expect those kinds of things, and it's best effort. So next. So now I'm going to show you, just like there are model scales, there are delivery scales, as Louis pointed out. So in the standard S-101 and S-102 formats, we have 3 scales, L2, L5, and L6, and you can see them on the screen there. And we have on the right of the screen, we have all our S100 products and the models they come from, and the levels that we're going to produce those files at. So what you should be noting here is that, first of all, some of this data is already flowing to Primar. Some of it's in production, meaning that the files are being created, but we haven't ported them out yet, and some of the stuff is still in development. Specifically, some of the stuff that's in development now still are the station data production of S101 and S111 and S104. But those require something we'll see later in a different slide, some more details. But next, you can see we have numbers of scales, but we have this what's called latency. So when the models run, they have to run all sequentially. That means that if we start a run solution at, say, 0 UTC, the first model, GOPS, isn't done for an hour and a half. REOPS is not done for 4 hours after 0. COPS West, 5.5. Salish 500, that's running at the same time, so it's the same time scale. Then the next piece, which is our SOS Salish C, which is 150 meter resolution, that is 7.5 hours later from UTC. And then the high resolution solutions that we have for South Fraser and Vancouver Harbor are 8 or 9 hours after 0. So when we make a forecast for 48 hours, when it comes out, it's already 9 hours old. And if we have, and that's obviously partly a resource issue and part of the reality of how these systems have to work, particularly if you want to have them fully matched all the way through the scales, which is what these systems are being set up as. So next. So then we have the levels of the S100 products that we're going to produce from them. We have probably not going to make something at GOPS. We were questioning that. Well, for REOPS, we're going to make level 2, and we're making level 2, and you'll see that. For COPS West, it'll be level 5, or the COPS will be level 5. Those are in Operations and Environment Canada, and we have experimental production of those files, but it's not ported out yet, and we need to wait for that to be fully integrated before we can make that happen. And then at the Salish and SOS Salish C solution levels, we have level 5s or 6, and we get to the Vancouver Harbor 20 meter, 30 meter resolution. We go to level 6, which is the red tiles, which are basically about 2 degree tile size, 2 meter resolution. And sorry, I should have told you, level 5 is 1 degree tile scale, 10 meter resolution grid, and level 2 is 1 degree with 100 meter resolution grid. And so the last reason we're doing all this, next, Louis, is that we want to do the full meal deal. We want to provide information for in-transit, for approach, and for port and channel. So next. So now what we're going to see is some of that data flowing onto MSDI and on that ArcGIS viewer. What you see in the top left is the REOP solution, and this is undersampled, so it could be viewed on the screen. The resolution is much higher than that, as you can see in the 2 cutout images, which is the actual native resolution of the models themselves. We're in the imaging that we're showing, where the IHO file spec for how arrows are supposed to be shown is shown in the bottom left. There's a color map, but also a scale size. We're not actually using the scale sizing on our displays at the moment. It makes things much more complicated, just the color maps. And this is a level 2 tile. So So basically, we've taken the model output, sampled it on level 2 tiles, produced S-111 level 2 tiles, and then recombined them in MSDI to show you the combined image. So, and that's both the east and west coast. And if next, here we have the next one is, this is the high resolution Vancouver solution. So it's 20-meter resolution. The bottom panel, when you first look at the images on the ArcGIS viewer, it undersamples, so otherwise you can't see anything at the resolution. And then you zoom in, finally, you'll finally see the full resolution. And when Louis, and this is going to be, and again, we're producing level 6 tiles, and those tiles are then being fed to MSDI or the ArcGIS, recombined to produce the whole image. But one of the things that he was referring to is that, and the ocean scientists will also understand, is that interpolating or sampling an ocean model velocity set is a tricky thing. And it's in this case, what we have done is at the highest resolution, we have a 20-meter resolution model that we sampled at 10-meter resolution. We oversampled it, and what that does is produce artifacts in the solution. So, and we did this is partly because the implementation of using S-111 in the viewers, the viewers and those commercial entities want to make it simple so that they can easily do the job. And that means that they would like to have rectangular grids, but ocean models don't give you that kind of output. And so getting the two worlds to talk together nicely is a bit of a challenge, and we're still working on that. And so that's what he was referring to last night, that I suddenly realized, oh, look at that, we got a problem, but not a problem, but in our 500-meter resolution of the bridge, and we have twice as many errors as I expected to see. That's because we're oversampling at 10 meters. And then when we do that, and using nearest neighbor interpolation, we end up with these little issues that we'd rather not have, but we need to fix. Anyway, so that's that situation. The next one is going to be a video. So can you play? So this is the Vancouver solution running for a tidal cycle. And you can see that it's because of the high resolution, you recover the jet behavior of the inflow and outflow, and there's a lot of detail that it's hard to see in this image, but recirculation zones, eddies, etc., flow off. And I'm going to show in the next video a specific example of that. So in this one, we're looking at the channel, and if you look at when the flow is coming in, the inflow jet, the flood jet, you'll see that the currents coming into the jet are going from left to right, but in the bottom, there's a backflow because there's a recirculation zone. And the point of resolution is that the more resolution you get, the more you can recreate what is like reality. And as Isabelle said, sometimes resolution doesn't actually get you further ahead, but it does tend to provide better representation of things that actually happen in reality. And for example, you would have narrow shear zones and stuff if you went out and looked at it in the harbor. Okay, next. So this is a last discussion about the resolution issue. So we saw it in the currents, but here's in water levels. So this is going under the second narrowest bridge, again, in Vancouver Harbor. And this is a maximum flood and a maximum ebb situation. Unfortunately, when I put these figures on, I pasted over some of the numbers because I put them too close, so you can't actually see the vertical axis numbers correctly, but bear with me. So what you see in the image is that is going through the narrow channels, there's about a half a meter or more of change in water level over approximately 500-600 meters. And you can see the model pixelation in the images that show you the scale of the models and how it's resolving that transition. And so you need to have resolution to resolve that. And the question we have is, what is sufficient navigational resolution? We kind of concluded that that's reached when greater resolution will not materially affect the navigational outcomes, but where that resolution is and where that truth is still not clear. Next. So what we were looking at before was the delivery of gridded data from models, and that be forecast and nowcast data. But we also want to provide data from individual locations like tide gauges, current meter stations. And so to do that and to have it be able to be integrated into these machine-to-machine interface type of systems, we had to rebuild our entire observational product system. So we built what's called the integrated water level system, which is a cloud-based database with APIs, with all the gauge data feeding into it, and display applications attached to it, and additional applications will be attached to supposed to be in the coming year to produce the aggregated S-104 and S-111 files that would be used with the model output to provide shipboard comparative validation, because that's very important. That models are great, but you need to be able to see what's happening now, what's the model saying now, and that's how you can somewhat judge on the fly how good the model solution is. And these services also provide things like air gap, etc. And that's a new system that we built over the same period to move to digital transformation use of hydrographic products. Next. Last slide is the delivery system that Louis already talked about. We're positioned as the data providers. We have industry partners to provide the official services to pilots. The services were initially set up to service S-101 and S-102, and we're leveraging them to also supply S-111. So all the data you saw on the MSDI pictures that we showed is feeding is available to Primar now, and the intermediate scales between the REOPS and all the way down to those small ones, we're going to be adding the other port systems in the next month or two, and we'll have other similar discussions like this one. There's those regions when we do that, and then we'll also add those intermediate pieces after that. So we should have the entire chain of large scale all the way to small scale on the right product lines to provide the full service in both S-101 and S-104.
Thank you, Phil. So after the science, we've seen, what it takes to, move from science to our operational service. As Phil mentioned, this is our best effort. Of course, the expectation, we know the expectation for our clients is 24/7. We're working hard, to try to make sure that we're hosted on the 24/7 environment of Government of Canada. So we're totally working for that, but we want to be transparent. Today, this is our best effort. We expect good reliability on it, but if you've got issues, again, your feedback is important to us. And talking about feedback, I'll pass the mic to Marc Leblanc, CHS Pacific Regional Director.
Hey, thanks so much, Louis and Phil, for explaining. Exciting to have an S-100 layer being available, and the key is really to make this work right. We need your feedback. So for those of the non-nav users that are accessing the data, CHS info, send your message there. Somebody will get in touch with you and address your concern. Of course, for the nav issue, this is our new service. We really want it to work right. So definitely get your information into support at Primar. We want to make sure the data is available when you need it. And in particular for the coast pilots who'll be working closely with CHS, feel free to reach to us directly with the questions and concerns, and make sure that we get this initial layer working well, working right, and providing the information you need. So really exciting time for CHS. I regret I will not be part of the organization as we grow these S-100 layers and provide these new levels of service, but certainly it's a very important point in time for CHS to be able to do this, and your feedback and support is going to be critical to that development. So the fact that we have so many people on the call today is really encouraging. Thanks so much.
Thank you, Marc. So the last point on the feedback mechanism. So as Marc mentioned, if you've got for the non-nav, you go to CHS Info, and for the nav, you go to Primar that will be supporting the client, connectivity issues and how it works. And I want to introduce, our Q&A session with that. Again, we've mentioned that throughout the discussion today. If you have real world observation, because you're the expert in your local area, and you see that oh my God, like that doesn't fit here. Like what the model is telling me and what I see like doesn't match. We need to know when, we need to know where, we need to know what is the software you use. And of course, we would like to get the discrepancy, you know, your best description of what you see, and you send that to CHS Info. And you know, we'll see if it's will fill group, or dynamic hydrographic S-111 team, we're gonna look at it. And if it's really associated with the science, we'll reach to the ocean science branch and maybe all the way to the scientist and the modeler that developed that, to see, you know, what is the issue and look after that. So again, really important. So that concludes the formal part of the session today. Thanks to all the speakers, you were great in terms of timing. We have still a full half an hour to look at the questions. So please, I would like to invite my speaker to join me opening their cameras. And I'm repeating that I'm gonna try to handle the question period. You can use the chat, and you can also decide to raise your hand, and I'll give you the floor. Tell us what is your organization and go with your question. There is no stupid question. And as you're all thinking about, okay, do I go for my first question or not? And I'm not so sure. So I want to raise my, you know, as you can see, it's a team sport, S-111, Ocean Science Branch. Isabelle was the speaker today, but you know, Keith Lennon, all of the recent researcher and so on, great, you know, you were part of it. Phil's team, G, Maxime, Gilles, you know, they are the whiz behind everything happening. And finally, the Pacific CHS regional team, you know, they did go in the field to calibrate, to install sensors, to debug, and maybe they will be involved in managing the feedback we're getting. So great. Somebody is brave enough for the first question. Let me see. So we have a question from Matthew Kerr. So Matthew, if you want to open your camera, let's go for it.
Hey, good morning, everyone. Matthew Kerr here. I'm Deputy Marine Superintendent for Canadian Coast Guard Western Region. I'm just wondering, the ArcGIS data viewer has the time at the bottom there. Is that in local time or UTC time?
It's a good question. I should remember, but I don't. So you have to do some math using your tide tables and try to define it.
Yeah.
But I think we're trying to do local time.
Okay. Yeah.
So, but to be validated. But you know, you're starting hard with the tough question right off the bat.
Yeah, I figured.
So I like it. I like it.
Thanks a lot.
So let's go to the second question. Neil.
Yeah, good day, everybody. Neil Henney, Operations Manager for the BC Coast Pilots. I'm just wondering, for these dynamic products, what there was a comment earlier about, you know, there's a lot of data involved moving through it. What type of actual throughput levels are we looking at for data, especially given that the West Coast, a lot of it doesn't have, say, cell coverage or is completely basically a black pit of any kind of reception or connectivity issues. So that's obviously going to be one of our concerns. So what type of bandwidth or throughput requirements are we talking about for these, you know, S100 charts? And then if you know, that's just the S100. What about the S104, the S10, everything else that's on top of that? What type of actual requirements are we talking about for physical actual data that's going to be used, if you guys know?
Yeah, no, so, you know, Phil, I'm going to start, but I want you to complete. So sometimes when I speak about S100, I refer to a tsunami of data. So you're right with your concern. This is just the beginning. But in terms of the way we are providing the format is pretty efficient, and you know, Phil can speak to it. But the beauty of it is, you know, the minute you have connectivity, system should be able to grab the data. And if you don't have full connectivity for the next 48 hours, you're surfing on forecast. So you don't need to always be connected to get the latest. But Phil, do you want to add to that?
Sure. The file size we tried to limit that, and that's why we're going at multiple scales with different resolutions, so you don't have huge high resolution data being tried to put on a big tile. So when you're going into port, you'll need the port scale ones, and so that's a somewhat limited piece of data. But we should also be making available the traditional products in S100 format as well. So we'd be able to have the standard predictions from tide stations, even on-demand observations, which is going to be a light file because it'll only be a small amount of data. So those things that you would need now for a model comparison, which you got 12 hours ago, those things should be able to come much faster. But probably I would guess that if you would be able to, as you come into, if you're out on the far offshore, I don't know what your data throughput capabilities are anyway, so I couldn't comment on how quickly or whatever you'd be able to get the services that way. Presumably it's cell or satellite, but those throughputs out for you, I don't know. But when you're getting close, when you're into a local cell range, you should probably be able to get those smaller tile, high resolution products without too much difficulty. That's how they were planned.
Thank you, Phil. So I'm going to move to the chat. So we have a question from Brazil, and maybe I think this one is for you or Isabelle. Is there a converter for traditional model outputs? So we know that in the scientific domain, NetCDF and GRIB are usually or often used. So is there a converter for traditional model outputs to S111? And if so, is it possible to share?
Do you want me to take that?
Yeah, go ahead, Phil.
So there are converters, and they're not just Canadian converters. There's a Korean converter, there's a US converter, but they're still, I think, kind of in test mode. And then what I said earlier about converting from, let's say, NetCDF output to S111, then you have to choose these things about interpolations and things. So it's a bit tricky. But the answer is yes. You could probably get access to example converters that you can start testing with and playing with, and that's part of the IHO TIGWIG's agenda, is to make those things available so that HOs can start to play around with them.
We are also looking at some options for distribution of the NetCDF format, which is actually the native format for the underlying models. So just looking at what we can post where, essentially. GRIB is one that we're also looking at. We're aware that one's widely used in the recreational boater community in particular. We're not producing those right now. It's something that we're looking at what more it would take to distribute and, create and distribute those. So that part is more of a future activity.
Yeah, so the strategy, we could easily do a bunch of formats, but the reality is now we conform to the latest emerging standard, S111. We know it's going to take some time for industry to pick up. I would hope that in the next couple of years, S111 becomes, the real de facto standard for surface currents. And, GRIB, because NetCDF, to me, you can have so much flavor of NetCDF as S111. If a software developer develops with the IHO specification, technically, it's plug and play. You don't have any flavor of S111. Everything is written into the specification. So we have another question in the chat from Rachel Dugas. So in case where a gauge goes down, or the nowcast is held up by computing issues, would mariner be getting warning or information indicating the change in the quality of their S111 layers? Phil, do you want to take this one?
Well, I can try. That's partly the viewer's bailiwick as opposed to the data provider's bailiwick. So, how that is communicated to the user of a viewer based on what information the viewer has been able to obtain, that's their issue, and you will know what the latency of your files are because it'll be timestamped in UTC for it starts now and it's going for 48 hours in the future. So you'll know how old you are based on that. and you'll know when you weren't able to get the next one that should have been available, for the next day. But how it's communicated to your viewer, that's not up to us.
No, good. Thanks, Phil, for that. What I could add to it is, we're writing the book as we go, and in the modeling world, you kind of have a health of the system. If the inputs are getting in, if the high power computing machinery goes well, we have kind of a green light saying, everything is performing as it should be. But if we have like delayed input or CHS is doing a maintenance on an important tide gauge in Vancouver Harbor, so we cannot use that to anchor the model, now we're operating in degraded mode. So how we're going to tell that to the clients? Well, it's a good question. The other thing also is, and I know that Isabelle and the group, they had some ideas about that, is sensitivity analysis. We're trying to be efficient in the way we're computing this data, and maybe we'll see that, okay, even if we are starting to lower down the data simulation, maybe the impact on the model is not so hard when you're kind of a regular. But if, of course, we know that data simulation really saves the day when where we're outside, we've got this big depression coming in. Now really data simulation comes. And, you will also learn as a user, you will learn, how we cook S-111 and how it will be able to capture and sense, this difference. Because there's a lot of forcing or inputs we can leverage in the modeling world to make sure we mimic the reality. So thank you for the question, Rachel. We'll go to Paul Welling, so in the chat, and after that I'll go back to the hands. So thank you for inviting me. Very educational. One question about the time schedule to make S-101, S-102, S-104 available for the Great Lakes and specifically the St. Lawrence Seaway. When can we expect availability of this data? So Paul, I think I'll take this one. So today we're doing this focus session, West Coast model S-111. We are planning to do one for Central Canada. So, Great Lakes, connecting channels, St. Lawrence Seaway. So in the new year, focus on S-111 also. And as you saw, they were under the OPP. We also developed a high-resolution model for Canso and St. John, New Brunswick. So we're also planning a session there. So in terms of availability, we're almost there. S-102, it's a different beast. There's a lot of, there's also complexities on the S-102. But if you want to get ahead of the curve, I would encourage you to, connect with CHS. We can provide test data sets so you can start to look into your how this could going to be digested in your software. But we now have a challenge from IMO and IHO to be ready by 2026 with operational service with good coverage. Canada will be there. Okay, let's go to the hands. So give me a sec. I'm going there. So Thomas, please go ahead.
Hi, good afternoon, everyone, and thank you very much for the presentations. That was absolutely fantastic. So my question is probably directed at Phil or Isabelle. It's how you plan to make S-104 safe. And I guess what I mean by that is, in reality, it can't just be a case of 102 and 104 together, because there is a inherent uncertainty in the forecast. That I know it's not an ensemble, but it will have an uncertainty. So, and I know in the product specification, there's like a 95% uncertainty range, but then that's only like 19 times out of 20. So how do you think this is going to be like navigationally safe when it all gets going?
And Thomas, just for you, what is your affiliation or organization?
Oh, sorry. Yes, UKHO.
Thanks.
So I think there's probably two parts to that question. There's the model accuracy or uncertainty piece, and then there's the delivery of it. So maybe I'll let Isabelle address the first part, because the models were evaluated for their in a future forecast accuracy sense, and that was part of the CSAS evaluation. So maybe I'll let her take that piece.
Yeah, and I mean, honestly, it's a multi-step process, right? So in any case, whether you're dealing with tide tables, or I mean, tide tables are usually generated from some modeling and analysis as well, or current tables or atlases or models. There's the best estimate, and then there's some error bounds around that. The uncertainty estimation process is something that the forecasting community at large is working with right now. And this is something that actually we're having ongoing discussions right now in Environment and Climate Change Canada about how to provide information on what the uncertainties are, what the errors are, and when certain products should be used at different scales, this kind of thing. So that's an area we're still working on. This is where it comes back to sort of the limitations that I mentioned earlier, where we have a best estimate that's been validated against a 5 or 6 year span of data. That analysis gives us a good level of confidence that within those range of conditions, the estimates are comparable with the observations that we have and with the other models in the areas. Where you're sort of within that green path, the models are fairly reliable. But obviously, if you get into something where it's at the edges of that, where you're right at the edge of the model domain, if you're having a 1 in 100 year storm, those kinds of things, that's where there's some user caution required, and it has to be documented in the documentation and hopefully in the service. And so that's the ongoing process. In terms of how that's communicated, maybe that's something, Phil, I don't know if we have anything to add. I think that's where we're looking as a community for when we deliver those types of services, how to give that additional information in a way that's meaningful, obviously, because on the bridge of a ship is not a great time to be going through peer-reviewed literature, and we do recognize that.
So if I recall correctly, and maybe somebody would correct me if I am wrong with this, I'm pretty sure there are uncertainty values available in the S100, 111, S104 spot file specs. And one of the things that is interesting, if you want to think of it that way, is that even though the model's been evaluated against observations and data, they've only been done that way for a discrete number of points across the domain. So for 104 water levels, water levels don't change significantly in space unless there's a real good reason for them to do so, like a sill or something like that in the topography. But currents, that's a different story altogether, and they're time dependent with eddies, etc. And so providing an uncertainty estimate for currents is quite tricky. And I've had conversations with the modelers about that, and we've talked about it's going to be spatially dependent. For example, if you looked at those images underneath the bridge in Vancouver, you're pretty sure when the flow is going in that's the current direction, etc. But is that eddy off the side? Is that real? Is that where it's supposed to be? Is that exactly the time it's supposed to be there? That sort of stuff is a different question. So probably what that means is that for currents, even more so, it's a spatial representation of uncertainty, depending on the phase, etc. And to be honest, right now we would have bulk uncertainty values that are based on those observation comparisons, but having that spatial one, that's a tricky thing, and we'd have to do ensemble comparisons and stuff. And we talked about that, but we haven't got there yet.
So 2 great answers to a difficult question. Thank you.
Thank you. No, we like tough question. It's good. All right, let's go to Michel Breton, CHS Pacific.
Hi, everyone. Thanks, Louis. Great presentation, Louis and team. I had technical problem. I don't know if I missed that information, but I thought I'd ask the question. With the coast pilot authorities around the country, they use, as far as I know, different PPUs. So are they all able across Canada to test S-111 on the different PPUs, NavSim or CIQ or others? And are they all testing those new products in the 6 areas that you mentioned?
Yeah, so, in Canada, you name the different companies, we've got the NavSim, we've got the CIQ, and we've got Transas technology. Test data sets are available. Right now, if you reach to Primar, you have access to, a free 3-month trial for data. So, of course, this is what we want, but it's the user. If the user are all excited about what we just demonstrate today and they see that there's a potential for them, you know now on the West Coast what is covered at high resolution, and we have entire coverage at low resolution everywhere in Canadian waters. So the user, they will connect with their software manufacturer. But in terms of availability of data, I can tell you Canada has made the best effort possible to respect the international S-111 standard, and if a software company fully complies with the specification, technically should work. So I'll go back to the chat because we have a second question from Brazil. So are the S-111C current data information are related only to the surface or for the entire water column? Phil, I think I'm going to flip this one to you.
So at the moment, the surface currents are the average over the top 5 meters at the moment, but we've discussed and considered that there could be other, surface current representations we might want to also include. For example, a range of what we would call average surface currents, which would then be dependent upon the draft of the vessel in question. So, top 5 meters, top 10 meters, top 15 meters, and then it'd be average values produced for those individual depths. But at the moment, all we're doing is the top 5.
Yeah, and we know that I was involved in the definition of S100, S111 specifically. We know at some point we probably need to go in full 3D sort of currents. We're not there yet, but of course, as you can expect, my team has some ideas how to make it happen and influence maybe a future version of the S111 product specification. So we have another question online. So Miss or Madame Taillefer? Or Mr. Taillefer? Yes.
Yeah.
Martin.
Good morning. Great presentation. Marty Taillefer from D&D, Chief Oceanographer for CF Incom. Love the updates on the currents and tides. Is there a component in the work that CHS is doing that deals with particle drift modeling or particle drift assessments for losses at sea or objects losses to be able to assess the travel projection of an object or human in the water?
Okay, so from a CHS perspective, it's easy to answer. It's not in our mandate, so we're not doing that. But I think Isabelle has maybe some insights for you.
So this was actually the second part of the work that we did under OPP. So the goal of the models that we produced was on the one side for the navigation, so the current aspect, and then the other side was actually having those oceanographic conditions for drift prediction. So that's something where we have some capacity within DFO. So there was a sub-activity within the initiative on having these results and then using them for drift prediction. So using some of the drift prediction models out there with the model outputs to be able to, in particular, backtrack trajectories. And we've had some nice applications around everything from lost equipment to dead seabirds, deceased whales, search and rescue applications, and so on. In the end, though, the full mandate for drift prediction, especially for environmental response scenarios, is with Environment and Climate Change Canada. And so we've also been working with them for sort of longer term, how they might be able to use the model results for those applications. And it's something where we've been having some test scenarios and exercises in recent years. So the short answer is yes, it's an area of active work. We don't have anything scheduled right now operational other than the longer term activities with Environment and Climate Change Canada.
Okay, thanks. And just as a follow-up question, it's kind of related, floodplains and storm surges and all that. Is that still part of perhaps Isabelle's work and with Environment Canada, or is this still, or can this be related to what CHS is doing?
Yeah, floodplains and storm surges gets to be into an overall tricky area. You get into the interactions between the ocean and freshwater often. So I have a couple of my scientists online. So Michael, Rachel, and company, please correct me if I'm wrong. Well, there is an element, obviously, of surge prediction for the coastal parts of the model. Really looking at that floodplain work is not, I believe, something we're doing very much right now, other than in a research collaboration sense with our partners. But Michael, please fill in if I've missed elements.
Yeah, that's pretty much correct. Environment Canada does run a storm surge model, but I don't believe it's being ported into the S-100 series system. So, yeah, that's kind of out of our scope.
Is it possible to port it to the S-100 systems?
Technically, if we're talking about, the surface of the water, the S-104, that's the, water elevation. It could be captured in such a way in a full, digital twin approach. So yes, it has the S-104 had the potential, is all depending on the forcing you apply to it.
Perfect. Thanks a lot. Appreciate it.
Okay. Right. Merci, Martin.
Merci.
Going back to the chat, we've got specialized converter for getting CDF. So great, we have a bit of collaboration happening on the chat window, so that's great. All right, so we have 5 minutes left. I know you're all busy people, and if we have emptied the questions, I have a special request because I want to capture this special moment. So I would like everybody to open their cameras. I'm gonna close the PowerPoint, and I just want to take a screenshot of that to, set the stage and capture this unique moment of the first S111 briefing. So I hope everybody you enjoyed. We had a good turnout. I think I saw the maximum participant reaching 112, something like that. All right. Good. Almost there. So, and please, the CHS folks also take some grabs because I couldn't miss that. All right. And copy to clipboard. Great. Nice end of the day. Thank you to all national, international participants, and stay tuned for more.
Thanks, everybody.